Welcome back, everybody. Now we're going to do something very simple. Very simple. This has been around since I graduated high school back in 1985. Okay? It's called the Network Time Protocol. It's something new that started in the previous certification with CCNA 20-125, where we had to set the clock, right? The time, the date, the month, the year, and then the time zone, all right? And I'm like, oh, okay, whatever. But it is important because we need to make sure that everything is synchronized. So in the presentation that you're about to see is going to explain to you what NTP is and stratum levels and things like that. All right, and then at the end, you're going to see a lab on how to configure this and the show commands, the two show commands that come along with it. So pay attention to the presentation. NTP is not something that's difficult to do, but it's something that it is important to do because you want to make sure that all your devices in your network are synchronized correctly. They're all within a second, milliseconds, within each other. So if errors happen, you know exactly when it happened, okay? It's very important for that to happen, especially when you're duplicating domain controllers and all that stuff. Anyway, look at the presentation over and over again, and then do the lab right there from scratch. It's right there. You just gotta go ahead, pause the video, mimic it, and then just configure it, and you'll see that's not that difficult. But at least be aware of what you're typing and the output you're getting. You need to see that and memorize that, because that is what's going to be very important in the test. See you there. Hey, welcome back, everybody. Now we're going to talk about something that we're familiar with, or if you're brand new to networking, it's called the Network Time Protocol. Network Time Protocol. And there's different types of network time protocols. Don't think this is the only one. If you go out there in Google, you're going to get SNTP. You're going to get a whole bunch of different things. Simple network time protocol. There's completely different. There are different NTPs. This is straightforward NTP, Network Time Protocol. Now, why do we need to know how to configure or what this protocol does? Well, number one, NTP is the networking protocol for what? Clock synchronization between computer systems over packet switch variable latency data networks. Basically across the network. Okay, it's going to synchronize all your devices that are connected to the network so everybody can be, within milliseconds of each other, pretty much. Okay. So you can synchronize your domain controllers, your email servers, your file servers, your shares, your routers, your switches. Everything can be on the same page at the same time, right? The most important part about this is the fact that when we start getting errors in our company, all right, or in our home or wherever you're doing this, okay, if you have NTP configured, you get a timestamp. You get exact, time, date, When I say time, I also mean the month, the day, the year, the hour, the minute, the second that it occurred, right? We've all looked at event viewer, the log, all right? And it tells us, hey, this or this information or this whatever occurred at this time at this place. So we need to make sure that we should do this. We should have this. I'm glad Cisco is taking a more proactive approach to people actually paying more attention to that. I'm one of the ones that, before it was just like, just set your clock on your routers, meaning your time, date and year, and then your time zone, whatever. I didn't think much of it, but it is very important because we need to make sure that we're all running within sync with each other, especially when we start having issues, all right? So we need to know when they actually happened. All right, we don't want to have unsynchronized devices, all right, which, well, then we run into a problem. We want all our devices within a network to be able to be synchronized to each other. All right, now, NTP, well, just so you know, let me go back. NTP is, look how long it's been around, since 1985. 1985. So, like it says right there, it's one of the oldest internet protocols in current use. Internet because normally the N server or the end device that's actually synchronizing to the clock, the atomic clock, the NIST site or something like that, they're the ones that are giving everybody else, hey, this is the actual time, okay? So everybody sync with me, right? And we'll talk about that in a little bit. All right, so NTP is intended to synchronize all participating computers, I just told you that, to within a few milliseconds. It's pretty damn good, okay, of the UTC, all right, coordinated UTC. So it says we're going to say test you on your time zone if you're -4, +5, -23. They don't care. They just need for you to understand the importance. Did I say Microsoft? Well, it's Cisco. Oh, I feel like I'm doing Microsoft. Cisco only cares that you know what NTP is about and how to configure it if you had to configure it, and the commands that you look to show to see the times and stuff like that, right? Show the NTP associations, show NTP status, okay? Show NTP status and show NTP associations are the main two commands that we're going to be looking at. All right, so we definitely, when we're configuring our time zone, we use UTC, right? So if you want to just Google your UTC where you're at, you can just put it in there so you can be correct. It's not something you need to memorize, okay? I don't think you'll be tested on that. The protocol is usually described in terms of client-server model. And that's exactly what we're going to do in the lab, okay? That's what we're going to do in the lab. One's going to be a client-server, or two of them are going to be client-servers, and the other one will be the master, all right, which is the one that's actually looking at the atomic clock, okay, which is not, okay, because it's the packet tracer, all right, but we're going to set the time and the time zone in each one of these devices, so no big deal, all right, but it can easily be used to peer-to-peer relations where both peers consider to the other to be the potential time source, which in an essence, we're doing a client-server model because two of them are going to be client servers, so they're going to be pointing to the router next to them. But in reality, it is a peer-to-peer relationship because they themselves will be supplying the time. It's not going to be a centralized atomic clock somewhere that we're going to. So it's a little combination of both, all right, if you want to think about it that way. Now, the way this is, there's a hierarchical or order to this. Like it says there, a semi-layered system of time sources, which is called a stratum. Okay, so the A server or the synchronized to the stratum N server runs N+1. Okay, the number represents the distance from the reference clock. So normally the atomic clock, the NIST, right? They're the ones that we're synchronizing with. So that will be the master server, all right? And they will be running that, all right? So it'll be a 1 or 0, what have you. We'll look at the different levels now to see which is which, all right? And then it keeps adding 1 from that point on forward, okay? So again, the number represents the distance from the actual reference clock and is used to prevent cyclical dependencies in a hierarchy. So if you have an actual network that has a hierarchy, you want to make sure that the stratum levels are configured correctly, and you're not going to have more than 2 stratum levels or more than 1 stratum level. All right, so we know exactly who's who and how we're going to go ahead and get the right time and date, pretty much. All right, now here are your stratum levels. You got stratum 0. And these are the high precision timekeeping devices such as atomic clocks, GPS, or other radio clocks. They generate a very accurate pulse per second signal that triggers and interrupts and timestamp on a connected computer. Stratum 0 devices are also known as the reference clocks. So this is the device that's going to be stratum 0. That's going to be, hey, you are it. You have the actual time that we're all going to go by. All right, so that's what it is. The stratum 1, these are the computers whose system time is synchronized to within a few microseconds of their attached stratum devices. These guys up here. And stratum 1 servers may peer with other stratum 1 servers for sanity and check and backup. So stratum 1 can look at other stratum 1s, but they know just to make sure and everything's good to go, because all stratum 1s will get their information from stratum 0. Okay, stratum 0. All right, so far we got 0 and 1. 0 is the bomb. 0 is the man. He's the one that, hey, atomic clock, GPS, GPS, other radio clocks, all that stuff will be there. Okay, stratum 1, this is the one that look at stratum 0. All right, and he can look at other stratum 1s, but only to peer with other stratum 1 servers, again, for check and back. All right. And then lastly, we have stratum 2. These are computers that are synchronized over the network to who? Stratum 1, correct. Often a stratum 2 computer queries several stratum 1 servers. Stratum 2 computers may also peer with other stratum 2 computers to provide more stable and robust time for all devices in the peer group. Now remember, even though this says computers, we're going to be doing this on routers, okay? So no big deal there. We'll be doing this on routers, and you'll see how they'll talk to each other, okay? Now, there is some configuration need to be done, but we'll talk about that when we go on the actual lab. And then stratum 3, these are computers that are synchronized to stratum 2 servers. They employ the same algorithms for peering and the data sampling as stratum 2 and themselves act as servers for stratum 4 computers. The stratum 3 do for stratum 4, and it goes on and on and on. Now, the upper limit is 15. That's the highest it goes. If you go above 15, it's going to consider itself unsynchronized. So it's like RIP, all right? Maximum hop count is 15. So that's what the stratum levels are at. And I got a sneaking suspicion, okay, that in your exam, one of the things that they will talk about is the stratum levels, especially when it comes to stratum 0 and stratum 1, because stratum 0 is the one that is going to, the reference clock, okay, that's going to give you all the information. And then the stratum 1s, because remember, it's n plus 1, okay? So, and every other router, then 2, then 3, then 4, and so forth, okay? But you can do this just as well with computers than you can with routers or switches, okay? It's just a matter of getting that configured. All right, so what we're going to do now is we're going to go into the packet tracer. We have 3 routers set up, and we'll go ahead and configure NTP. See you there. All right, so here we are in the lab, and I'm already taking the liberty of configuring just the basic stuff, IP addresses, and I'm using RIP as a routing protocol. You can see here you have a server, you have 192.168.1.1, 192.54. We can check connectivity with this gateway, ping 192.168.1.254. What? No, that was just a weird IP address. 68.1.254. There we go, much better. And then just from right here, so we can see that we have full connectivity. We'll just ping 10.1.1.5 or 6. All right, we'll do 5 as well. I forgot which is which. All right, so we have full connectivity all the way across the network. Cool. So we're going to start configuring NTP. We'll come this way and configure it that way, because what I'm going to do is I'm going to make this router, like in your book, I'm going to make that router the master router. That's going to be the, yes, that's going to be the master router. But I need to know my IP addresses first, because did I do 5 here? I got to find out. Hold on. Okay. Sure IP. Should start. It's 5. All right, so that one's 6. So this is 5, 6. So this should be 9 and 10. Oh, Control Z. What the heck? Control Z. Control Y. Okay. Oh, because I clicked that. Ah, okay. Let me plug this in back to where it had to go to. And make sure it's correct. That what's supposed to be going down? The 00 is the LAN. Show IP route. No. Yes. 500 right here. Okay. All right. So this is 5, 6. This is 9 and 10. Obviously, like well, let's verify. We gotta verify. Always verify, even though if I configured it, you know, my brain's getting a little bit whatever. So show shows. I'm gonna show start. Now there's a huge library there. Yeah, it is 9. All right, so it's 5, 6, 9, and 10. All right, and this is not 1, which is the server. All right, so let's go ahead and configure. What we're going to do is we're going to call this. Remember, this is an NTP client server configuration. So this is going to be an NTP client. All right, and it's going to be NTP server. In this case, it will be your book is a different scheme. This is going to be 10.1.1.6. It's going to be pointing to that address because it's going to have the time. And then this one will be another client server, all right? And this will be pointing to this guy, which is 10.1.1.10, all right? And then this guy will just be the NTP master, okay? Cool. But before we do all that, we got to set the time and date. And I'm going to set them on all of them. We have an atomic clock, okay? So GPS or radio clock or whatever the heck it is, we don't have it, so we're going to have to configure it. So we're here on the very first router. Control C. Now in privilege mode, there is a clock command. Clock, and then you set it. What are you setting? The time. I don't know. Let's pick a time. 15 colon 15 colon 00. Right? Military time. And then what? The month. What are we? April. April. And what day is it? Let's call it April Fool's Day. And we know the year. All right. So we set the actual time and date. All right. So we go to config T, and now we're going to set the time zone. So we're going to do clock again, and then we're going to do time zone. It looks for a word, meaning, you know, okay, where are you at? Florida. And I think mine is -4. You're not being tested on this, okay? That's it. So we're going to do the same thing to all the routers, right? So all the routers have a clock set up, okay? So let's go ahead and do that. Now, what time did I put on here? I put 15:15. Okay. So let's go ahead and do Control C, config T, and I'm going to do. Oh, I didn't have to do that, did I? I'll put clock. Let's question mark our way through. That's what the question mark's for. Set. Hour, so it's 15 colon 15 colon, I don't know, 01. Okay, and then we're looking for a month, which is April. And then we're looking for the date, which is April Fool's Day, and we know the year. Then we put the time zone, so we gotta go to privilege, clock, time zone, -4. Enter, incomplete. Oh, I forgot to put the name. Time zone Florida, -4. All right, DWR. I'm gonna do the last router. Okay, and then we'll do clock, set, hours, 15 colon 15 colon 05. Oh, it's 25. 05. What is it now? Month. The day of the month. I'm sorry. The day of the month, which is it's the month. April. Okay, then the day of the month, April Fools, and then the year. Cool. We have that set. So, and then the time zone, clock, time zone, Florida, and then -4. Cool beans, man. We got that going. So we're going to fast forward through time, This is going to be your best friend in the packet tracer. I'm telling you this right now, to make things work. Right, to make things work. So now we're going to do some show commands. Let's take a look at over here. This router way over here. One of the first commands that we're going to do is the show NTP status command. Enable show NTP. If it's not running, it's not running. No, right? It is enabled. I configured it. I just did WR. I configured it. What do you mean it's not configured? Show NTP status. Oh, no. Did I? No, I didn't. I just configured the clock. I'm sorry. Oh, I gotta tell it. Okay. Config T. See, I told you it would tell you. NTP server, and I'm gonna point it to the other guy, which is 10.1.1. Oops. 10.1.1.6. Oops. 10.1.1.6. Okay. And we're just gonna leave it at that. Do WR. All right. And then we're gonna point this guy to routers, the other router, right, to the right. Enable config T, and we'll do NTP server, and that's going to be, what is it, 10.1.1.10? Yeah, it's going to be 10.1.1.10, and then that's it. Okay, do WR, T, basic. And then this guy, we're just going to make him a master. Okay, and then we'll say global configuration, NTP, and there's a lot of things you can do here, as you can see. But we're just going to set master, and you can set the master to 1 through 15. Remember, 15, after that, it's unreachable. So he won't be 1. Let's say he's 2. Okay, like it says in your book. All right, that's the lab they do. So, you know, I'll follow along just like, you know, so you can see what we see. They didn't do the running protocol or anything like that, all right? And they talked about the clocks and all that, but I'm actually doing it for you. All right, and I'm fast forwarding to time to make sure everything happens. Let's go. Okay, so now we come over here, and now I've enabled it. Show NTP status. Oops, I almost forgot. Let's show NTP status. Yes, NTP status. All right, one of the things that we're going to look at is that it's synchronized. There's a stratum whose the reference is 10.1.1.6. Okay, 0.00 milliseconds. All right, that's pretty cool. All right, the precision, saying that correct, right? Precision. Okay, it's telling you it's April 1st, 2020. It's giving you this time, even though I put 15, it's telling me 16. That's okay. It's a packet tracer. All right, but take a look at that. Okay, stratum 4. Over here, enable, show stratum. No, okay, show stratum. Show NTP status. If I can spell it. All right. Stratum 3, one less that guy. Okay, one less that guy. It's synchronized. That's what we want. It's stratum 3. It's looking at the master. All right, and look, within the same time, UTC, April 1st, 2020. All right, we're doing good. Now let's take a look at this guy. What does he have? Enable, show NTP status. So he has, he has a lot of information, isn't he? He's stratum 2. That's why the other one was 3, and then the other one was 4. That's n plus 1. So if I would have put 0, it would have been 1, 2. If I would put a 1, it would have been 2, 3. So if I put 2, this is 3, 4. Okay? But he's his own reference. That's why he's pointing to his own loopback. Okay? He's pointing to his own reference. Okay? And you can see the time right here. Okay? That's what it is. The other command that you can do, and let's use this router since he's the furthest away. All right? We'll do show NTP associations. All right, here it's telling you, okay, well, 10.1.1.6, the reference clock is 10.1.1.10. Okay, 10.1.6 is my neighbor. 10.1.1.10 is the reference clock, that's the master. I am in stratum 3. How many times it was pulled, the reach, the delay, the offset. So it gives you all this information. These are the 2 commands that you need to be aware of. The show NTP associations and the show NTP status. Show NTP status. Now, we have a server here. Okay, let's see what happens when I go into the server and I go into services, because there's NTP in here. That's all by default. So look, see, that one has the right time. Well, I put 1515, put 1539, whatever. It's the packet tracer. It's not being clocked into anything. But it has the right date. It's April 2020. All right, and it's today's date. Well, it's not today's, tomorrow's date, actually. All right, so, but it's working. It is working, okay? It is working. All right, so you can do that. That's NTP. Obviously, in a real world scenario, you're going to have a device or devices that will connect to an atomic clock. You'll have one, which will be 0, and then stratum 0, and then you'll have other ones. Well, other devices will be on stratum 1, and then you have stratum 2 and 3 and 4 and so forth. And then your computers will use that to synchronize themselves. Remember, if you're having domain controllers that are synchronizing with each other, you have email servers, you want to know exactly the time and the time and date that you got that email, or the time and date that you received that error. So even though this may be something simple, something easy to do, this is something that's very important to do, because we need to know exactly what happened, not only what happened, thanks to our SNMP and syslog and NetFlow, but when did it happen? Okay, when did it happen? So that's the importance of your network time protocol. See you in the next one.